let's find another easy. Length of the last word. Given a string S consisting of words and spaces, return the length of the last word in the string. A word is a maximal substring consisting of non-space characters. The last word is world with length 5. Okay. Okay. So we need to, basically, ignoring spaces, find the last word. So I'm gonna create a variable called end, and I'm gonna set it to s.length. Basically, the idea is I'm going to work my way from the back of the string and work my way back character by character. First, I'm going to find the first word and mark its ending. Then I'm going to find the beginning of that word and mark its beginning. So let end equals s.length. We are just assuming that the length, that the end of the word is at the end of the string, but we're going to write a loop that says otherwise. We're basically going to be n minus, we're going to do s sub n minus 1 equals empty. We'll do n minus minus. Basically, while we're looking at an empty string, we need to keep going. And then next, we're gonna have to find let start equals end. And basically, while s sub start is not equal to empty, well, not empty string, the space character, we're gonna do start minus minus. And I think we have to do let's just start minus 1. And I think we do end minus 1 because we know that we hit a character. Do we? I guess it's possible we hit the beginning of the string. Just to handle an edge case of, for a reason, this is, let's look at the constraints. S contains only English letters and spaces. There will be at least one word. Okay, there'll be at least one word, so we can do this to add a sub optimization. But basically we could do return end minus start. So we could run this, see how we did. We do get passing code. Now, something that I can imagine other people did was probably doing a s.trim split on space characters dot at minus 1 dot length. This is like if you wanted to do it in one line of code, I think that this would do the job. But one line, you gotta think about the in terms of optimization. I mean, we could do trim end as one optimization for that chunk of code. So s.trim end, I mean, that's trim end is it's fairly expensive because you need to create a new string, and creating a new string is automatically going to be big O n. split regex, that's, I mean, it's going to be big O n. You're going to create multiple strings again, and then we get the last string of that split and then get its length. It's just like a lot of overhead. Now granted, because these are probably running in C level code, they might be super fast, even faster than this code, which is something to consider. But I don't know, I just don't think that it's likely to be that much better. Let me just run it one more time with our code, and we'll just submit it and see how we do. Wow. So for this one, I think we have to do start is greater than 0. Otherwise it just keeps going. Okay. We could probably also do this, and we'll still be for better. You can't really do better than 0 milliseconds though. But I am curious what the runtime of this is. Wow, okay, it is super fast. I will say that this might not be what a interviewer is looking for. That this is more likely what the interviewer is looking for. So I would go with this solution. Let's look at an alternative best solution. So they did do similar to what I was saying. Instead of doing at -1, they did a pop. They did a split. Interesting. So they trimmed both sides, which we discussed as slower. They replaced every set of spaces with just a single space, which is kind of unnecessary. You don't really need to do this. So it's an extra step, because ultimately the only thing that matters is the last word. It doesn't matter how many other items you get. This is just adding extra work. Split here, I use the regex, and maybe this is like, it could be, I imagine that this is faster than a regex. But I mean, they could have, if they're already doing a regex, you could just do the regex here. I didn't have to do a regex per se. And then they pop, which is basically getting the last thing, and then get the length of that last thing. So they did a solution that I thought somebody might do. Let's look at another solution. Slightly slower solution. Last length 0, last char is space false. So char of S. It would be good to have a declaration of let or const here. If char is, so for some reason, okay, so last char is space means is the previous character that I looked at a space, yes or no? And if the last character was a space, then and I'm looking at something that's not a space, then I'm going to reset the length and say that it's not a space anymore, and the length will increment at this point. So basically, the issue that they had for this algorithm was they did it forward to, they went all the way through the string, which, you know, both algorithms, mine and theirs, they're both big O, but that's the worst case scenario. The average case, or best case scenario for my algorithm is it only goes from the back till the first word. Their algorithm always goes through every single character. You see, that's just for of S. There's nothing breaking out of this loop. So they always go through every single character. So that's why this is going to take a little bit longer. We'll go to this one. See if we can figure out. Oof, that's a doozy. We do see this idea of working our way backwards. And then while I is greater than or equal to 0, while S sub I equals, we're going to increment the, it's not equal to, okay. Okay, so basically they're going like character by character-ish, and initially they're going to, like, if there's just spaces at the end, this for loop's just gonna run until finally we find something that's not a space, and then we're gonna hit this while loop, and then we're gonna increment count, we're gonna decrement I, and then we're gonna look for a space again. Or if I is going out of bounds, then we return count. So basically, it's fairly similar to our algorithm. I'm surprised that it's that much slower than the previous one we were looking at. This ran in 2 milliseconds, this ran in 1 millisecond. Because they're still working from the end. They're not doing that many comparisons. Like, how expensive is a console log? Like, is that gonna increment by a millisecond? Anyway, they're doing it, they're doing what we did with a little bit more variables. I mean, what does this flag variable do? So they just declared this variable for no reason. They logged for no reason. They created length for no reason. I mean, I don't, yeah, because this only happens once. So just putting this here instead of this, I think is totally justifiable. Okay, let's look at the 3 millisecond. Okay, and this one's just going in order. If we see a space, the total becomes 0. This is interesting. Oh, because we trim first. I was gonna say, because if there's spaces at the end, then this is not gonna work. But since they trimmed, they could have trimmed end. But other than that, the issue is they went in order. Maybe this trim adds a little bit more time, because it's doing the left and the right trimming, creating a whole new string. And then we have another trim. Got the length, current word. Ooh, okay. Yeah, that'll be expensive. String concatenation is very expensive. Current word plus dot length, it's very expensive. So rather than just keeping track of the number, which is all we care about is the count, they kept track of the actual word, which, yeah. This would be like essentially n squared, just doing this. because every time you're concatenating a string, you're creating a string with 1, then you're creating a new string with 2, which requires you to go through every character, creating a string with 3, which requires you to go through every character. If you keep doing that, you get the sum of numbers from 0 to n for 1 to n, which is an n squared, big O n squared algorithm. Okay. Alright, we gone through all those.